Now, this is the way that we all often think of the internet. I mean, how many people know this map? It's an online webcomic from an online webcomic called XKCD. If you haven't seen it, it's fantastic. If you're coming to these talks, you should probably read it. It's a lot of fun. But the guy behind it made this map. It looks familiar. It has a lot of things that when we say the internet, you think, oh yeah, Facebook, it's in the news right now. It was huge back when the map was made in 2010, YouTube, Skype down there, there's probably Google and so on. But these are the services that we use every day. So when I say the internet, we're often thinking of these services, right? We're not thinking about what lies beneath. And in fact, some of the early literature on the internet thinks of the internet exactly this way. You go back to Manuel Castells and his first volume of the Network Society trilogy. He tells us distance. Now, in the network society, whether it's physical, social, economic, political, cultural, for any given point, no position varies between 0 for any node within the same network and infinite, right? For any point external to the network. The architecture of relationships between networks enacted by light speed operating information technologies configure dominant processes and functions in our societies. It was a hugely influential a point of view when this was initially published and continues to have a great deal of valence. When I started studying these problems, I of course encountered Castells, but I found limits to it in what I wanted to study. When I started looking at the infrastructure, the actual work of operating these systems didn't seem like distance was between 0 and infinite, right? Which is the experience that we have of the surface that we interact with every day. Nor did it seem that, in fact, these were light speed operating technologies. But rather, they sometimes look a lot more like this. Right? So these are submarine cables. The bulk of the world's international internet traffic, telecommunications traffic, flows over systems like these. There are ships laying them, there are people maintaining them. It takes a lot of work and capital to build these systems. And so I came to the work of David Harvey, right, who points out, well, if you want to think about how capitalism functions, it has to fix space and immovable structures of transport, communication nets, and so on, in order to overcome space, to achieve a liberty of movement through low transport and communication costs. So the point being, if you want to achieve this world that Castells points us to, the network society, you actually need to fix capital in particular locations before you can start to imagine the space on top. But that wasn't satisfying either, as much as this was really useful to set up a conversation. Because the question remains, how do you get from this stuff down here, the physical infrastructure, the Wi-Fi router that I'm sure is somewhere in this room, right, to this virtual imagination that we have, to the surface that we interact with every day? And what I came to, and that was, in fact, if you start to look at the work that people put in, the practices of the technical communities that operate these systems, that actively produce those spaces, going from physical to allowing this virtual interaction to appear to us. Now, that, I think, has significant implications, as I started with, for thinking about problems of governance. Right? And there's a broad field of internet governance studies that's been growing over the last few years. A lot of it deals with the Internet Corporation for Assigned Names and Numbers. Anyone familiar with that? ICANN? They are a nodal agency that oversees the allocation of domain names. So every time you click on a website, you put something into your browser's URL bar, google.com, right, facebook.com, ucsd.edu. These are all names that have to be registered at some level through the hierarchy organized under this agency. So it's one kind of global governance that makes the internet go, because names must be globally unique. Now, so how do we start thinking about these problems in governance? When we say governance, again, as I started with, often we're thinking about some kind of interaction between state, market, and civil society in order to negotiate relationships between labor and capital and these other entities, right? To say, well, at one level, governance is a problem of just maintaining order within a system. At another level, governance is a progressive act, right? It's of trying to be inclusive, trying to overcome certain differences and so on. So there are two very different perspectives. One saying we want stasis and order, and another saying no, we want progressive change. But they're both functions of governance that you could think of in these ways. In the internet world, the most popular way of thinking about these problems is with this model that is called multi-stakeholder governance. And the idea is if you bring all the right stakeholders around, sit them inside the same institution, represent all of their interests, then we can start to produce a governance of equal viewpoints. And it's often contrasted to older models of governance like the UN or the ITU, where nation states had sway. With multi-stakeholder governance, often corporations have an equal seat at the table. Civil society might have an equal seat at the table. Other groups might come to the table. But it's never quite entirely fixed. And so ICANN, the Internet Corporation for Assigned Names and Numbers that I mentioned earlier, calls itself a multi-stakeholder organization, right? And it is interestingly, for a global governance body, is not a global agency, let's say like the UN or the ITU. It is in fact a nonprofit registered in California, right? Not far from here. That is its legal form. Right? Nation states actually have no seat on the ICANN board. They have no vote on the ICANN board. They function in an advisory capacity to the ICANN board. And the board is by and large corporate representatives along with representatives of civil society, broadly construed, coming in very particular ways. So that's one model that we have that makes the internet. Yeah.
Quick question. That used to be different, right? ICANN didn't used to be as independent as it is.
Well, ICANN went through a bit of a constitutional crisis a few years ago where people around the world, governments in particular, were saying, well, we don't trust you. You are an agent of the US state. And in fact, you exist under a contract from the US Department of Commerce. That transition happened, I think, probably a couple of years ago. They moved away from that model. But they're still a Californian nonprofit, and nation states still only have an advisory role. There have been efforts by the ITU and the UN to capture ICANN functions at different points in time, but they've been firmly rebuffed, often with support of the US government, which again has made for a very interesting and complex politics. Is that, yeah, okay. So that's one model of governance. So I'm just trying to give you an example of what that can look like. Another model comes from the work of Milton Mueller, who looks at the internet and says, no, in fact, what we have is this new model of governance, and I'm going to call it networked governance, right? So we have all these different entities, whether they're corporations, whether they are, open source software advocates, nonprofits, and in fact, they're functioning together in these broad networks. And it is the structural form of this network that institutes a new kind of politics, right? And governs through distributed relationships of coordination within the network. And so, in his account, the politics of the nation state that tries to control from above, the politics of international governance organizations that try to control from above, in fact, are very effectively rebuffed by these networked forms of organization. And then we have a third model, right, which Johnson and Palfrey, building on the work of Yochai Benkler, who Benkler talked about open source software, and peer production of open source software, and so on, called peer production of governance, and saying, look at the internet, look at the way that standards are formed on the internet. The Internet Engineering Task Force that sets many of the technical standards for the internet, for instance, is, at least in their account, a spontaneous gathering of people. And it is through these people just coming together. We don't actually care about what their connections are and what actual work they do in relation to each other. It's just that you put them all in a room and spontaneously we start to get these governance functions like standards development, resource allocation being met through these very spontaneous forms of order. Now, all of those, as you can imagine, giving a brief survey, bothered me in different ways, because as I was starting to study the practices of technical personnel, I didn't see multi-stakeholder governance accounting for what I found in the field, nor network governance, nor peer production. There were very grounded practices on people engaging in work on the ground. So here are a couple of pictures from a meeting of the North American Network Operators Group. The one on the bottom is from a meeting of the South Asia Network Operators Group. Right? These are both professional organizations of people who operate networks that make up the internet. The one on top, NANOG, I'll start using that for short. meets 3 times a year, right, at locations across North America, as the name might suggest. The one below, SANOG, meets twice a year, alternating between India and other countries within South Asia. They're doing very different things across these 2 different pictures, and I'll come to that in a minute. But the important thing that becomes very apparent, that became very apparent for me in my fieldwork, and might be apparent to you from these pictures, is that these are now no longer abstract models of governance. These aren't structural descriptions of the world. These are people who have gathered in physical locations, right, who are negotiating with each other, working with each other, building relationships, right, before they go back and actually operate their networks. And in fact, some of them have their laptops open, are monitoring their networks and doing work, even while they're at these conferences, to build the relationships they need to make the systems go. And in that, I started to draw from the work of Henri Lefebvre, right? And to think about the internet not as these 2 different layers of space, or there's this virtual space up here and this physical space down here, but rather as a space that is actively produced, right, through lived, embodied practices of people sitting in places, people traveling across geographies, right, and really engaging in work and relationship building that allows the production of the internet. Now, I'll get into my fieldwork in a minute, but before I do, let me take you through a little tour of a key word that I'll keep coming back to over time, which is this notion of trust. Why do we care about trust? And why do we care about trust in particular when we talk about problems of governance? Right? At a general level, this is a problem that is part of everyday social reality. You engage in an interaction with someone else, there's some risk and uncertainty attached to it. How do you overcome that risk and uncertainty in order to actually engage in that social interaction? Right? Now, broadly construed, this might be interpersonal. You go to your neighborhood store, you're buying something. Right? It might be at a much broader level of, oh, do you trust your government? Right? And we use this word trust very loosely in these different contexts. Now, one solution to problems of risk and uncertainty is what is, at least termed in the literature, an assurance structure. So now these 2 people don't need to trust each other anymore. They just have confidence in this assurance structure and say, oh, we have confidence that this thing is reliable, therefore that structure is taking on our risk and uncertainty and allows us to interact. So for instance, I go to my neighborhood store, I hand over a piece of paper, right, which has printing on it that happens to be money. And the paper money works because there's a central bank that assures both me and the person behind the counter that this piece of paper actually has value. Right? Whereas in itself, it's probably worth nothing. But it is the symbolic value assured by the central bank that allows us to engage in that interaction. Here's another model. Right? I go to the store and I was like, oh, I'm sorry, I forgot my wallet today. And the person behind the counter says, oh, well, you know what? I know you. We've been here a bunch of times. How about you just bring me the money the next time you come? Now, he's able to do that because now that person behind the counter trusts me. Right? It's like, I know you. I've interacted with you. We've had repeated interactions over time that have allowed me to form a judgment of who you are. Right? I judge you to be trustworthy. And in forming that judgment of trustworthiness, I choose to trust you in this moment. Now, there are a bunch of other perspectives on trust that we could pull in here, but I want to focus on this relational aspect. So there are others who will talk about cultural notions of trust, or trust as an emotional construct, as a cognitive construct. But I would really like to get into this relational notion here. Now, when you expand this to society at large, we start to think about it as, trust as the management of expectations, broadly. It's like, oh, we're able to have a stable society, right, because we have a central bank. For instance, we have a system of laws, right, and we have expectations of others' behavior in our interactions because we have these assurance structures that allow us to have expectations of the world, right? And so, for instance, in the work of Giddens or Luhmann, Giddens calls it trust in abstract systems. Luhmann calls it system trust. And they say these are aspects of modernity. right? You turn your tap, right? And at least, let's say if you're in San Diego, you assume that the water is clean and that you can drink it. Right? Maybe, not so much. In Berkeley, I make those assumptions. But there's an assumption that there's a system that is somewhere out there that we have no visibility into, that we have no control over in that moment, that we can't make a choice over, and that we don't even think about, right? That goes behind providing the assurance that the water is clean, the money has value, the laws stay in force. Another way is like you start thinking about society formed through broad relationships of trust. Right? Interpersonal trust relationships as people interact with each other. These are often on account of social networks. So when you do social network analysis, as many people have done, it's, well, who is linked to who, in what ways are they connected, right? How would we start to use those interactions to provide an account of the world? Now again, these two are not mutually exclusive. These are models of the world, right, that allow us to start to form some judgments. And finally, there's a notion of generalized trust, right? It is, well, within this culture, people tend to be more trusting of others than in other cultures. There are problems with some of those assumptions, but again, it's useful to kind of allow us to step back a moment from what is the ground upon which we're forming trust relationships within a given society. And so, for instance, when I, as an ethnographer, walk into a NANOG meeting, what is the ground upon which the people within that meeting are judging me? Right? How are they?
Sorry, what's NANOG?
The North American Network Operators Group. Right? Sorry. I will be using this shorthand. I apologize if acronyms seem abstruse at any point. Raise a hand and ask me, like, what's NANOG? Right. But in all this, there's an interesting point that Ernst Gellner makes, where he points out that trust is a very paradoxical quantity. Right? That perfect order in a society, a perfectly governed society that has an assurance structure, the Leviathan that looks after all, right, requires no trust. No one needs to trust anyone else because we all rely on this centralized assurance structure to provide order for us. But in fact, that it is anarchy, perfect anarchy, that requires everyone to form trust relationships, because that is the only way that some kind of social order can be formed. And again, these are idealized views of the world. But the paradox is, in order to have trust, we must have risk and uncertainty that we as individuals are cognizant of and are taking on in interactions with others around us. Now, what does all of this, like this quick tour of theory, have to do with anything, you might ask? And I will now get to my fieldwork and hopefully provide a little more insight. My research began with this incident back in 2008 for, let me go back. I'll bring that back in a minute. But back in 2008, in January of 2008, for a couple of hours, the internet thought that YouTube was in Pakistan. Right? If you tried to go to YouTube, you would be redirected to a block page at a server in Pakistan. And in fact, the load of requests was so high that that server went down and no one could get to YouTube for 2.5 hours. Now, what had happened was the government of Pakistan wanted to censor a particular video on YouTube. They issued an order to the Pakistan Internet Exchange, which is a nodal point for connectivity for networks within Pakistan, saying, block this video. The Pakistan Internet Exchange chose to block that video using this protocol, the Border Gateway Protocol, or BGP. BGP is a key infrastructural technology of the internet. Now, you may be more familiar with domain names because that's what we see every day, the domain name system. BGP, the Border Gateway Protocol, is a technology which allows networks to interconnect with each other. Right? And I'll talk about that more in a minute. But the Pakistan Internet Exchange decided that in order to block this one video, they were actually going to hijack all of YouTube's address space. And they were going to make an announcement to all of the networks within Pakistan saying, you know, the route that you think you need to use to get to YouTube, the IP addresses you think you need to get, you should traverse to get there, those are all wrong. We actually have a better route to YouTube. If you have any traffic to YouTube, send it to us. And then they're going to put up this block page saying, oh, YouTube is blocked. They didn't configure that quite right. And this claim that they knew where YouTube was spread upstream to their international connectivity provider in Hong Kong, and from there it spread to the rest of the internet. And so the internet's routing tables at large thought YouTube was in Pakistan, and traffic from around the world started going to Pakistan. And this, of course, confounded me, because if a website as large as YouTube, with a company as large as Google behind it, can be hijacked by the Pakistan Internet Exchange, why is the internet stable at all? It shouldn't be. Right? This should be happening all the time, and we should not have a stable internet. Why is it stable? And that became the puzzle that I unpacked in my earlier work. As a corollary to that was, why was it designed this way in the first place? And I won't be getting to that second question today, but I'm happy to talk about it. Now, to get at this, as I said, I did field work at the North American Network Operators Group, or NANOG, as well as in South Asia, the South Asian Network Operators Group, or SANOG, and looking really at questions of infrastructure, right? As you know, Starr and Edwards and so on have given us these notions of, well, you know infrastructure when it breaks down. These are the moments when it really becomes visible. And this was certainly a moment at which the infrastructure all of a sudden became visible, and all of our cute cat videos went away, and people actually stood up and took notice. But as I started studying this, I realized, in fact, BGP fails all the time. There are constant failures, and these are well documented when you look into these technical communities. These are things that they talk about. I'm still on some of these lists, and scarcely, a month goes by without someone reporting a hijack of someone's address space. But it's the coordination within those groups that starts to remedy these kinds of issues and allows us really to see a stable internet, right? And this stable surface, the stable notion that, oh, when we put YouTube into our browsers, it will always work. Now, how is the system put together? I'll take you through a brief tour of some of the technology behind this so we can put the practices in context. Now, the way, if you read a computer science networking textbook, they'll often talk about a 7-layer model of networks. More practically, I think networks look more like a 5-layer model. We can split hairs on that in any case. But down at the physical layer, you have the actual infrastructure, like submarine cables, like copper phone lines, optical links, radio waves, Wi-Fi, and so on. At the data link layer above that, you have different technical protocols that run on top of those, like Wi-Fi, which you're all probably familiar with. Above that, at the network layer, lives the internet protocol. So every computer in this room has an IP address. All of your phones have internet protocol addresses. And this is how they get to the internet. This is how the internet gets back to them. Above that, there are various transport protocols that have different expectations of how data is transmitted. And above those come application layer protocols, which again, many of you will probably be familiar with. Things like HTTP for getting on the web, SMTP for sending mail, FTP for file transfer. Now, what's interesting about this, and it's often referred to as a stack, is that when you look at the stack, there's one place where there's only one protocol. Right at that middle layer, at the network layer, there's only one protocol, the internet protocol. And it becomes this really crucial hub through which everything else flows. And so in many ways, this looks more like an hourglass with a very narrow waist than a stack, because everything has to flow through that nozzle of the internet protocol. And so therefore, the politics of this layer, everything that happens in here, is something that we really need to unpack if we are to understand how we can imagine a different kind of politics up here, even while we claim that we're overcoming the politics of territorial logic down here. Now, what does this look like in practice? If I was sitting at home, that's me, right? If I had hair, and I'm trying to get, let's say, to ischool.berkeley.edu, where I got my PhD, what would happen? And if I run this command from my computer, I would get something like this. It traces the route of the hops that my traffic is taking. First, I go to I'm in home. I keep hopping through different things. Then I get to my ISP, sonic.net. Goes through sonic.net for a bit. Then it hops over to NLayer, goes through that for a bit. and eventually gets to berkeley.edu. Now, in this, you'll see you've got IP addresses, these numbers, like every computer that we're traversing. You've got these AS number following this. Those are autonomous system numbers. So every individual network on the internet is technically termed an autonomous system, right? And each individual network has a number attached to it. So the UC Berkeley network, for instance, is autonomous system number 25 because it got the number very early on. And I apologize, I should have checked on what the San Diego autonomous system number is, but I'm sure we can find that out. But we're hopping to all these autonomous systems. So when we look at this, on the one hand, we're saying, oh, we're actually moving through different kinds of physical infrastructure. Even at home, I know that I'm going from Wi-Fi, right? When I'm going from my laptop to my router, once I get to my router is going over Ethernet from the router to my modem at home. And then my modem's connecting over copper using a protocol called PPP to get to my ISP. Right? And then I have no idea what the physical infrastructure is down here because I can't even see it. But what the internet protocol does, as my earlier diagram suggested, is it smooths over all those different physical infrastructures. We don't need to know what they are, and we don't need to know where they are. Space, all of a sudden, is elided, right? In at least this kind of account of the world. But what this account does give us is a sense of organizational structure. I know that at the very least, I'm going from my home network that I have control over to my ISP's network, sonic.net, where data's hopping through, to some network called nLayer, onto something called transit rail, onto Scenic, which actually provides connectivity for all higher education institutions in California. So UCSD's connectivity too, I'm sure, goes through Scenic, and then to Berkeley. Right? But the question then becomes, how do any of these guys know which route they should take in order to get to berkeley.edu when I say I would like to go there? And the answer comes, like in BGP, when we start to think about how maps work, right? How do routing maps get created? If you lived in San Francisco, maybe a century ago, that might be what your postal map looked like. Right? If I was sending a letter to San Francisco, let's say from India, the postmaster would say, oh, this is going to the west coast of the US. Maybe it has to land in Los Angeles. Who knows, right? When it lands in Los Angeles, they say, oh, you're going to San Francisco. We don't care about the rest of the address. We have a map that tells us it should go to the central post office. Goes to the central post office. They look at the address, and they say, oh, this is this particular region within San Francisco. We have a map that tells us where that is. And it goes to that regional office within the city. And then the regional office says, oh, we have a street address. Now we'll send someone to deliver it to that street. But that system works because we have centralized maps. And we have a centralized agency, a single agency maintaining all of those maps. The internet doesn't work that way, as I've already alluded to. We have many networks interconnecting. There is no central agency that makes the maps. So how do we know, in order to get to berkeley.edu, that we have to take this particular path? Well, and that's where we come back to the border gateway protocol again. And in general, the technology is called interdomain routing, that you're routing traffic between these different networks or domains on the internet. And the way it works is UC Berkeley, well prior to the moment when I was asking, send my traffic to berkeley.edu, announces to Scenic, and UC Berkeley is AS25, autonomous system number 25, announces to Scenic, which is autonomous system number 2152, I'm UC Berkeley. You know me, we have a contractual arrangement, we have a direct physical interconnection of our network somewhere, right? So you know me, these are my IP addresses. If you have any traffic for these blocks of IP addresses, send them to me, because I know how to handle those. Scenic then announces that to all of its peers, one of which happens to be Transit Rail. There could be many other networks it sends this announcement to. It says, I'm Scenic, you know me, we have a contractual relationship. I can carry a traffic to UC Berkeley. Here are UC Berkeley's IP addresses. So, and then Transit Rail gets something for those blocks of IP addresses. It knows, oh, Scenic is actually a path that can get them to where they need to be going. Transit Rail in turn makes that announcement to nLayer, and nLayer makes that announcement to sonic.net, by which time you're going through like many different layers of claims. I'm nLayer, Transit Rail told me it can get to UC Berkeley through Scenic. I can carry your traffic there, send it to me. And everyone's trying to attract traffic, especially the most centrally out to the internet, because that's how you make money. People are paying for you to carry that traffic to the rest of the internet. So UC Berkeley is paying Scenic to carry its traffic, just as I am paying Sonic, my ISP, to carry my traffic. So money flows from the edges inwards, right, in a way. So as you get to these more central agencies, they're really trying to get more routes and say, the more people who are sending traffic through us, the more money we make. That's how the business works. But what's interesting in all of these claims, right, there are routing claims here. It's like, how do we get things to particular places? There are identity claims about, I am so-and-so. Right? There are resource claims about blocks of IP addresses that you claim you can carry traffic to. But what is fascinating about BGP, there are no warrants for any of these claims. There are technologies now being built that have been built that aren't widely deployed at all yet, that allow cryptographic verification of these claims. But in the internet that we have even today, there is no way for anyone to actually verify all the claims that are being made by these different agents, which is why Pakistan could hijack YouTube, because there was no one watching for that claim being made. There was an assumption, you could say, well, maybe YouTube set up a data center in Pakistan, then it would make sense that the Pakistan Internet Exchange was announcing YouTube's address space because it's a regional data center. That makes perfect sense. Who knows? There is no central agency overseeing this stuff.
Just to clarify, that it was an accident that it propagated upward? Pakistan didn't hijack
Yes, right. It was an accident. There have been intentional hijacks as well over time. There have been hijacks where the entire address space of the internet was taken down by individual networks. And there are histories of those things. I'm happy to point you to more of those if you're interested. And to give you a sense of the scale of this problem, there are currently about 60,000 autonomous systems that make up the internet, 60,000 individual interconnected networks that make up the internet. And across them, they're announcing about 712,000 blocks of internet protocol addresses. It's not individual addresses, but people announce blocks. This picture is from San Diego. There's a research center called CAIDA here, I think the Center for Applied Internet Data Analysis. They've been around for a really long time. Every year or so, they generate these nice pictures where every dot there is an individual autonomous system. Right? And you can see the connections between these. The ones towards the center are more highly connected. Right? This gives you a sense of the scale of the problem that we're dealing with. If anyone can hijack anyone's address space, if no one can warrant these claims, how do we start to even respond to this problem in the absence of a centralized assurance structure? So when I did my fieldwork, I'll give you a couple of brief quotes. Here's what a network administrator in North America told me, something that a good economic sociologist might tell you as well. In the idealized world of humans not being social animals, you have really, really high quality, low friction, functioning contacts everywhere you need to. But the reality is that the problem with the internet is that people with whom you have no direct adjacency, that is, your network's not directly connected to them, or any direct contractual or financial relationship can ruin your network. So the Pakistan Internet Exchange could ruin Google's network, at least for that period of time. And, another piece of that story that I should relate is the way that the internet got repaired from that particular failure was that Google started announcing more specific routes to YouTube. Right? And while those routes propagated to the internet at large through the Border Gateway Protocol, YouTube contacted, that technical person at YouTube contacted their counterparts at this upstream network provider in Hong Kong, who then disconnected the Pakistan Internet Exchange to prevent that spurious announcement from propagating. Now, again, another fascinating detail. Effectively, the bulk of a sovereign nation's international internet connectivity was taken down through private administrative action, where there was no contractual relationship at play. Right? These are mostly guys saying, you know us, we know you, something really bad is happening, can you take care of this while we try to fix everything else? And as someone else told me, this is how we make things work. There's lots of communication through back channels, like the Google guys calling up the network in Hong Kong. Lots of unofficial communication. There's lots of things that nobody can officially talk about, but if we can all share information about it, we can make the internet a better place. So there's lots of communities, and the only way that you gain admission into a community is to be a trusted individual. So this notion of communities that you have to gain entry into, that by proving yourself to be trustworthy, not just as a person, but also as technically competent.
So I was really struck by the definition that you shared of trust earlier. So is trust, in your view, that one's interlocutor has the ability to do something that they elect not to do in the service of a social contract to you? It came out fancier than I meant it. Is that roughly right?
It's like, does it prevent them from engaging in bad behaviors?
Well,
right?
But if the interlocutor didn't have the ability, then your point is that no trust is required. Trust is required when somebody has the ability to do something that they choose not to do.
The interaction, you're engaging in a social interaction that has some risk attached to it. If the interlocutor had no ability to harm you, then there's no risk attached. The problem doesn't hold. But what was fascinating about this quote, on the one hand, it's pointing to communities within which trust is formed and a need for a community to judge someone to be trustworthy. But equally, it's pointing to a shared concept of the internet that perhaps isn't the same one that we all normally think of. We can make the internet a better place. It's also an ideological stance, and something that I came across in my fieldwork where people talked about doing things for the good of the internet. Right? So these technical communities have a politics of their own that, again, doesn't reduce them just to agents of their corporations and so on, but also people who, functioning within communities, feel an obligation to one another and saying, oh, I know I'm going to be in a different company tomorrow, but I need you, my colleagues within this community, to hold me as being trustworthy and hold me as being someone who has the same vision of a common internet that we are maintaining together. Because if I'm not, then perhaps I won't be able to get my work done. And this plays out in places like the North American Network Operators Group. So this picture is from a really fascinating session at NANOG that happens at every meeting called the Peering Coordinators meeting. Peering coordinators are technical commercial personnel who negotiate interconnection arrangements between networks. So they're business people, they're also very technical people who have control over their routers and so on. It's unusually organized for a conference. Most of the sessions at NANOG, people sit like this, in chairs facing the front. A single speaker holds forth. At the peering coordinators meeting, for the most part, it's changed over the years, but the chairs are arranged in concentric circles. Right? And the people in the most central chairs know each other. Like the first time I went in, it was like, there was all this banter and joking. The person speaking can't get a word out because everyone's talking over them and like pulling their leg. And the people towards the edges of the circle, like me, right, were just finding our way in, not sure why we were there. Like other people around me, it's like, oh, it's my first time here. How do we behave? We weren't quite sure. And in an odd way, they're very much a community of practice made concrete, where you had people who were in more central positions engaging in practice with very strong relationships that they'd formed with each other, with others of us who were more peripheral, trying to find our way in towards the center. But what was fascinating about this, among many other things, was that you are officially, by convention, not allowed to report on the content of discussions that occur within this room. And as an ethnographer, that was a nightmare. It's like, so now what do I do? This room is so fascinating, but what do I do with this room? And the story became that, I can't talk about what happens in the room. Why do these people need a room in which they create a safe space? Right? And they need this because in order to negotiate their interconnections, they need to be able to find information about where people are developing their networks. So, oh, we're planning to move to such and such city within the next few months. Oh, you're coming there too. How about we pull out cables? That might actually be good for both our businesses. Oh, this particular data centers opening up a new branch over there. They'll be providing new interconnection facilities, but they're able to share information securely within this room. And many of them would say, oh yeah, the bosses know that we do this, but they just turn a blind eye because they know that this is necessary in order for the market to function, right? This isn't an ideal disembedded market. This is a very social space of people who know each other, joking around, but have also creating a safe space for themselves. So in many ways, when we now start to think about the internet and we start to think about technology, it's as much people sitting in rooms in particular places engaging in negotiation as much as it is the particular forms of technology. Let me give you another picture. This is from the South Asia Network Operators Group, where I sat in on a week-long training teaching young network operators to use the border gateway protocol. And we were organized around these two long tables. The instructors had set up virtual machines that groups of us could use, and our task was, we would run through exercises saying, well, configure your networks this way, connect this way, advertise these addresses here and those there, set up these different relationships. And then as we went through exercises, they would review them, push, cast them up at the front, cast configurations up at the front of the room, and talk about how people went wrong, working through issues, and saying, these are very practical problems, we deal with this all the time. And being very clear, saying, look, you could get this from a vendor like Cisco or so on, but the information that we give you is actually more substantive because we're not vendors, we're not telling you how a particular piece of equipment works. We are practitioners who are telling you how the stuff works in practice. These approved problems that we all see all the time, we're working them out together in practice, which is why these exercises are designed as practical exercises. When we were configuring networks, often I would get up, walk around the table, talk to someone else, says, oh, I've configured my end of the connection. Have you turned yours up? Oh, it's not working. Can we look at each other's configurations and figure out what is going on? Now, this is part of most people's everyday practice, trying to debug the interconnections. Oh, something isn't quite working right. How do we work this out? We have to work together. All this practice is a collaborative practice for maintaining these interdependent systems. The instructors, this particular SANOG meeting I went to was in Pokhara in Nepal. One of the instructors was Nepalese, who had since moved to Singapore for a job. The other instructor was a New Zealander who worked in the US. They had both flown in for this particular meeting. So again, producing the internet, producing these systems of practice is very much about putting people in a room in particular places, having bodies move in space from one place to another to transmit practice and build those relationships over time. And so the internet starts to look a little more like this. There are a variety of network operator groups around the world that have very porous boundaries. Anyone can attend these meetings. I didn't have to do anything special to go to the South Asian Network Operators Group or the North American Network Operators Group. Pay the registration fee, you get to walk in. If you're a student, it's not very much, so that worked really well for me at the time. Now, those act as hubs that allow these loose confederations of trust relationships to be formed, right? Both regionally and across the world, as people circulate between these different places. And those, in turn, sit on top of this technical commercial organization of interconnected networks. But of course, as I've been alluding to through all of this, this is a spatial problem. Right? In these relationships between NANOG and SANOG, like when I went to SANOG, I ran into people that I'd met at NANOG who had flown in to provide training. Right? Equally, when I was at SANOG, I was talking to people who would say, oh, what's NANOG like? I really want to go sometime. This is part of their local imagination. We know about this other, this sister organization to us that is really significant, and we'd love to check it out at some point. But they're these circulations of trust and practice that require movement of bodies in space, right? That aren't this technological production of this virtual space that's somewhat spontaneous. And as I was saying, there are various other network operator groups across the world. LACNOG in the Latin American Caribbean, AFNOG for Africa, Réseau Internet Protocol Européen, RIPE, in Europe. My favorite, Apricot, the Asia Pacific Regional Internet Conference for Operational Technologies. And there are also various other NOGs at various scales across the world.
So I'm surprised you say they're not technological, because it seems like airplanes are pretty critical to this architecture.
Yes. Well, when I say that they're not technological, I mean that they involve bodies moving in space. And yes, that involves technologies for bodies to move in space. And yes, it involves mail lists that all of these organizations maintain. Yes, it involves the physical technologies that they're actually working with. But I think I was trying to push towards the point that the assumption of the internet is that it's this technology that is automatically produced. And if only we can get the technology right, then everything else follows. And perhaps I'm pushing much further in the other direction to say, no, in fact, if we can get the social relations right, then everything else follows. And in fact, I would argue that if we can imagine a certain kind of politics of the internet, if we make claims around a certain kind of freedom that the internet offers, in part it is because of these distributed social relationships that go into producing it. Right? That constitute a very different model of governance than that we normally encounter in the world.
Well, but social relations are critical even if the people don't physically move. I mean, even if the body stays put, social relations can still be central.
And I think that works insofar as you're dealing with the top layer of the internet. The point that I'm making is, in order to even produce that top layer, you need bodies moving in space, which confounds many of the accounts, at least our commonplace wisdom of what the internet is. Various other NOGs around the world, and these in turn are anchored by centralized agencies like, I talked about the Internet Corporation for Assigned Names and Numbers, ICANN, the regional internet registries that hand out internet protocol address space and autonomous system numbers within the regions, the Internet Engineering Task Force that sets standards. Did you have a question? Right. So, not to say, oh, this is a happy community where people are spontaneously producing these relationships. No, in fact, a significant amount of work goes into it. And in fact, there are a number of nonprofits that are raising money to allow these people to fly around. There are companies employing these people that are willing to send them to these conferences. So it's not to say that this is somehow divorced from the system of capital as we understand it. Right? It is very embedded within it. But within that, somehow, it is producing a slightly different kind of social formation that isn't merely a subject of capital. Right? And in this, as I was saying, all of a sudden, our account of how we get from the physical infrastructure and produce the space of the virtual layer starts to look very different in these people moving in places and these institutions. And with that, I'm going to move to my next project. But any questions? Yeah?
Sir, real quick. Judging by the pictures, the answer is probably 0, but how many people in these rooms are not men?
Good question, and very few. Right. It's I think worse in South Asia than it is in North America. It's not great in North America. In North America, there are support groups of women who function within the North American Network Operators Group and go off and have their own lunch. There are framings that many men have of, this idealized notion of women's work. Oh, women are more social, therefore women are better peering coordinators. This is an account that I often heard. Yes. But that said, there's an interesting trajectory to the way that women have moved within these systems, where there were many more women in the early years of the internet and many fewer now. And I'm told that I have 5 minutes left and I haven't even got to my next project. So let me see what I can tell you that would actually be useful about this information security project in 5 minutes. What are my cute cat videos doing to my computer? So now when we think about the problems that we have in information security, at least two big ones are one, we don't have enough people to fill the positions that we have. The other is that we don't have enough cooperation to respond to the problems that we're facing. The way that those normally get solved, again, from a governance perspective, is we find novel problems, right? We find new bugs and so on in the world. We write them down, we publish them. Once they're in books, then we can put people in classrooms, as you do at UCSD, for instance, or at Berkeley, give them degrees and certifications, and hey presto, you have a trained workforce. Equally, you could say, oh, we have this problem of interdependence, right? There are all these different bugs coming from different places, there are attacks coming from different places. In order to resolve them, we must cooperate. The way that that's solved in information security is often through these institutional mechanisms, like computer emergency response teams, computer security incident response teams, information sharing and analysis centers, law enforcement, and so on. The idea is if everyone can share information about the attacks that they're receiving with a hub, that hub can then redistribute them to everyone else. This is confounded by a problem of confidentiality, because if I found a new bug, I can't, if I just publish it online, I don't know who's getting it. The bad guys are going to get it and exploit it as much as the good guys might get it and patch against it. I need to be responsible about my disclosure. And that tension militates against these institutional explanations of learning and cooperation. We have an institution that provides a learning function. We have an institution that provides a cooperation function, but how do we maintain confidentiality of the knowledge that needs to circulate across both these contexts?